Physics Chapter 2. Projectile Motion.
So let's look at 13A. It shows a car moving with constant speed of 80 km per hour when suddenly the driver sees a cat 50 meters straight ahead of the car. The driver's reaction time is 0.5 seconds and the maximum deceleration of the car is ms -2. So here you can see that 80 km per hour has to be converted into meter per second. We will do that later. And the driver reaction time is 0.5, which means in the first 0.5 seconds, the driver will continue its motion at a constant speed of 80 km per hour. So during this time, the driver will drive at a certain distance. So we will add it out when we do our calculation later. Now we are going to calculate the total distance traveled by the car from the moment the driver sees the cat until it stops. The problem is we have to see whether the car will stop before 50 meters or not. So let's write the information given down. The initial velocity is 80 kilometers per hour. Now we have to convert it into meter per second. One 3,000. This is because 3,600 is equals to 60 minutes. 1 hour has 60 minutes, and also 1 minute has 13 seconds. 60 seconds. So the answer that we get is 22.22 meters per second. So this is the initial velocity that we have. So as we know, the driver will stop at last, so the final velocity will be 0 meters per second. Then we get the deceleration is equals to 10 meters per second square. It is a deceleration, so the acceleration will be negative 10 meters per second square. So now we are going to find the total distance traveled. Right? So we can now apply to the linear motion law. There is 4 types of law, but now we are going to use this law because we only have acceleration, velocity, and inertial velocity information. So now we have to sub all the information that we get. Okay, so now we can find the distance traveled while it is decelerating. So how do we find the distance traveled during the first 0.5 seconds? So we just have to use as we know, distance equals to velocity times time. So during the first 0.5 seconds, the driver drives at 22.22 meters per second, and it lasts for 0.5 seconds. So by doing this, we can find the total distance traveled by the driver at the first 0.5 seconds. So to find the total distance, we just have to add up these two readings. And the answer will be 35.80 meter. And this is the total distance of this question.
For questions 2, which is sketch acceleration against time graph to show the motion of the car. At first, the car is moving in a constant speed, which means that there is no acceleration. Why? For example, if we draw a graph of V against T, it will form a straight line, which means there is no gradient form. So for our acceleration against time graph, it will start at 0 until it reach the second of 0.5. After 0.5 seconds, the car decelerate for 10 meter per second square. So which means, as we know, it's decelerate. So the value will be -10 and not +10. So the graph will be like this. Sorry. But to complete our graph, we need to count for the time here, which is I use the formula A equal to V minus U per T. So the A will be -10, which we get from here. V is equal to 0 because the car will stop and the initial velocity will be 22.22. So this is over the time that we need. So as we count, we will take time here and just change these two position. So we will get 0 minus 22.22 over -10. And we will get the time will be 2.2 seconds. 2.22 seconds. But this only for this is 2.22 seconds. To get this value, the value on here, you need to 2.22 seconds plus with 0.5, which is we get 2.72 seconds. So our complete graph will be like this. This one is A, down. So this will be -10. This will be 0.5. And this will be 2.72 seconds. So that's all. Don't forget the unit. Okay.
Okay, now let's look at question B. It is stated that a man runs off a horizontal diving board with speed of 2.5 meters per second. So we can draw the diagram out. And falls into the swimming pool at a horizontal distance of 5.0 meters from the end of the board. So this is a projectile motion question. So here will be 5 meters. So since the question states that the man runs off horizontally, so definitely the angle with theta will be 0. There will be no angle. So we will have to list out the information that we get from the question. For x component, ux will be 2.5 and vx is equal to ux, so it will be 2.5 also. For ax, we know that it's 0, and for the displacement for component x, we know that it's 5 meters. You can know here. So we do not know the time. For component y,
Since we know that the man runs up horizontally, so uy will be 0. And we know that the acceleration for component y will be negative 9.81. And the displacement for component y is negative h, which is here. And the value of h is the question that we are being asked, because that question asks us to determine the height of the diving board above the water surface. So later we have to find the value of h. And for t, we do not know also. And for velocity, it's not relevant for this question, so we do not have to find it out. So we have to find the value for h, right? But for component y, we do not have enough information to sub into the 4 linear equation. So we have to find t first from the x component. So I use the equation Sx equals to 1/2 ux plus vx t. So from this equation and we sub in the value, then we can find the t. So we can find that the t, the time is 2 seconds. So we can use the t equals to 2 seconds in y component. So for y component here, we sub the value here in another equation, which is I use sy equals to uy t plus 1/2 ay t squared. Sy is negative h, uy is 0, times 2 plus 1/2 negative 9.81 2 squared. So negative h equals to negative 19.62, and we get to find the h. The value of h is 19.62 meter. So we get the final answer, which is the height of the diving board above the water surface is equal to 19.62 meter. All right, that's all from us. Thank you.